Okay, the big data means there is a 3V concept which was defined by the IBM. The 3V concept is data volume. First V is volume, and second V is data velocity, and third one is the data variety. So these 3Vs are concept of your big data. Big data is not the software. Big data is one of the platform where you can able to have multiple software for data analytical field. This big data is it's not a kind of application development software or application development field. It is purely an analytical oriented field. So in this 3V concept, you can able to find a data variety which is having this structured, semi-structured and unstructured. It can be anything like a text file or video file or text XML file or CSV file. Any file type you can able to give us an input file for data processing. Each input file will be converted into a 64 MBs of data block. The data blocks is going to process in your client PC. Okay, and then it has the data volume. It has the terabytes, gigabytes, exabyte and petabyte and zettabyte and attobyte level of data you can able to process over here. That's the kind of data volume. If your data size is less than terabyte, is it advisable to go for a big data? No. If your data size is less than gigabyte or less than terabyte, it is not advisable to go for your choosing your application development or maybe a data processing or data analytical in the big data or Hadoop. But if the data size is more than terabyte only, you have to choose for the big data or Hadoop or whatever the technology which is you are trying to implement. So the data volume will matter over here. And data velocity in terms of here, you can able to process in the very faster way. So that's why here big data is most wanted technology. You can able to process even 10 terabyte, 100 terabytes of data within few minutes of time. So there is a new technology, or maybe it's not a new technology, that new technique how they are redefine this framework is, it's like a distributed data processing. Okay, the distributed data processing, which is a concept, previously it is the client server model. The client will request to the server and server will process and respond back to the result. But in big data, the concept is totally different. It is a master and slave concept. So previously the client will send a request and server will process. Now server will send a request to the client and client will process all the data. So that's a concept of big data. Okay, it is totally a distributed data computing. Okay, one computer is connected with the one master, and if 10 computers, 10 client PCs are connected, it will process 10 times faster. Okay, for example, consider in your college or in your office, if 100 jobs are there, if 100 jobs if I give to one person, it will take for one job to complete, it will take 1 minute. So if 100 jobs need to be completed, it will take 100 minutes of time. Rather, I am giving to one person and I'm giving to 100 members of 100 members of in the office or in the college. So every people will complete their work within a minute, so that within a minute I can able to complete all the jobs. So that is the distributed data processing. Okay, so any doubt on this 3V concept? Shall you move to the next slide? Okay. Okay, so this particular big data, why it is so popular is there is no much infrastructure cost. For example, in the client server model, you have to manage multiple servers. Okay, for if you're having SQL server or Oracle server, you have to invest a server, and that server itself cost itself around comes around 3 lakhs to 5 lakhs. But normal PC, client PC, maybe around 30,000 to 40,000. It won't take much cost, right? So for data storage and anything, if for example, in even the server, you will have 1 terabytes of 1 terabyte or 2 terabytes of hard disk only, as with the backup of 1 terabytes. Okay, but if I want to process 10 terabytes of data, how I can able to process in my server? It is not possible, right? if you are using the client server model, either you have to invest the new terabytes of hard disk you have to purchase, and then you have to keep on add as a slave hard disk, then only can able to process. So but in this technology here, the slave PCs, if you want to connect any number of client PC, you can connect over there, so it will save your cost. So there is no much investment on the for the cost over there in the infrastructure side. You can use the cloud computing also for data processing. Okay, so be aware of the till the terabytes of data, since we have the data volumes in the hard disk terabyte. After terabytes, 1024 terabyte equal to 1 petabyte, 1024 exabyte equal to 1024 exabyte equal to 1 zettabyte, 1024 zettabyte equal to 1 exabyte. Okay, so that is the different size of volume. So if the size of volume is more than terabyte, it is advisable go for the big data or Hadoop for data analytical. So currently Facebook is using producing 1.5 petabytes of stored photo. So where and all this technology are using is, there are many applications are currently using big data and Hadoop. Okay, it's not only for internet like a social media. There are so many healthcare system, banking software, many CRM softwares that people are using the this big data and Hadoop. So computer industry completely shifting now to before, like they are developing the application. Now people are moving towards on the data analytical problem and then automation. These two field only people are growing now. So more focus on this particular automation and then big data and Hadoop. So that will give you the your best career life in the IT industry. So hope you are clear on this volume, velocity and variety. I'm moving to the next topic. So next concept is 4V concept. So previously the 3V concept is defined by IBM. So IBM only defined in the year of around 2003 time, they have defined in the 3V concept: volume, velocity, variety. That's a concept defined by IBM. And there is a 4V concept in the big data. Okay, we are having the data, volume, veracity and variety, everything's fine. What is the I'm going to use for, if I have 10 terabyte of data, what I'm going to use with the data? Okay, that comes the value. So using that 10 terabytes of banking data, if you're having 1 terabyte of banking data or 1 terabyte of healthcare data, what you are going to do with the data? Okay, you're going to read that data, then you are going to apply your business logic to extract the business content over there in the data. Then you are going to make a output as a business insight or revenue generating kind of model of data. Okay, using the data, what is the output I can able to get? So such a way you have to think through that, apply your business logic. That's called value for your business. So volume in terms of, there are 40 zettabytes of data which is going to create in the 2020, and then there are 2.5 quadrillion bytes are every day it has been created. In the most of the US companies having more than 100 GBs of terabyte, 100 terabytes of data volumes are stored, and 6 billion people are using mobile phone. People are using mobile phone for many purposes, so that is increasing the data volume. And velocity in terms of, for example, this New York Stock Exchange, 1 terabyte of trade information are having. For example, if you want to purchase a stock in the market, I need to analyze the okay, this particular stock will be going up or down. So we may not be aware of that, right? So we have to see the past historical information, how this performance happening for the particular stock. If your content is more than 1 terabytes of volume of last 10 years of the trading information, you can easily process in a very faster way using big data and Hadoop. Based on that, you can make a decision making over there. So the big data and Hadoop will process your 10 terabyte of data, and then it can able to provide you the output. Okay. Then variety in terms of, it can be processed at the big data of any kind of variety. For example, if Facebook, if you take that, it does not have any kind of proper structure, right? So you can upload photographs, you can upload the text, you can upload the comments, Twitter, you can apply the feedback, text comment or images, anything you can able to possible, or video files. So these content need to get readed, and then you can able to have the analytical of customer sentiment analytical, or the social analytical, or healthcare analytical, or banking analytical. So any kind of information you can able to extract, and then you can able to process. And the data volume size, even though it's more than terabytes of terabytes, no need to worry. It can able to process using the big data and Hadoop softwares. Okay. So other content we are going to study about what is the difference between a RDBMS and then MapReduce. So big data is a concept which has been found by the during the year of 2000, and then it was started from the Google company. Okay, the Google has been as a search engine. When the people are searching the many search activity in the internet, they are unable to handle many lakhs of search to update the storing and retrieving the data of URLs. So they want to optimize this search. So during that time, what they did, they want to store the Google search and retrieve in a very faster way. So what they did, I'm just going to give some 1 minute of demo. Okay. For example, if you consider hard disk sector, if you consider how the data are storing and retrieving here is, people are storing, and so everyone is storing and retrieving through hard disk. The hard disk has sector, it containing the zeros and block. Each hard disk sector is containing 3 KB, 3 KBs of block size. If you want to store and retrieve the 1 terabyte or 10 terabytes of data, and 3 KB will be very small block size, so it will take very long time to read and write the process. So what they did is they have made this concept called Google file system. The Google file system as the technique of storing and retrieving in the 6464 MB of block size. Google file system. So this Google file system, whatever you are storing and retrieving in that particular platform or particular the file system, it will store and retrieve in the 6464 MBs of block size. It will be on top of your hard disk, the logical layer of 64 MB data block. Okay, so that you can able to find the white paper related to that. It was found in the 2003. So they found the how to store and retrieve the large data. Then they have found the how to process the particular. Once again, the another concept called map reduce concept. Okay, we are storing and retrieving the multiple large data, but how fast we can able to process it in a faster way. For that only they found the map reduce technique in the year of 2004. So since it's a research paper, it has been published as a white paper. Then the Yahoo also similar kind of search engine during the best search in the year of 2000 time, and then they're also facing the similar kind of problem. So they taken that white paper and then they have created a platform or software for that. That is called Hadoop software. They converted the GFS Google file system as the HDFS Hadoop distributed file system, and then they have applied the MapReduce concept for developing the Hadoop software. Okay, so that is the main concept of big data. And then we are going to understand about the Hadoop. Okay, so Hadoop is the one of the software which has been developed by docketing is Java. He's developed into Java platform. The Hadoop framework, which is the allow for a distributed processing for large data set across the clusters of commodity computer. Commodity computer means your normal PC. Okay. Apache Hadoop is the open source software. You can able to download and use it in the any kind of software. It is available in the apache.org. Okay, so Apache Hadoop histories we already saw about. In 2000 it was published as a Google file system, and then it was 2004 it is published as a MapReduce concept. Based on that concept only this has been evolved. Okay, so the MapReduce concept you need to aware. The MapReduce concept, which has been each block size is 64 MB of block. Each value will be get stored into a key value. There is a key comma value pair concept only. The map and reduce will work. So if you're having 100 GBs of data, 100 GBs of data will be split into multiple 64 MBs of block. Each block will be compared with the another data block. So these data blocks will be get compared with the key comma value pair concept. If your data business logic, if you're applying this business logic data will be compared with the one block with the another block. So it will be data will be get compared with the data block 1 of key comma value. The value is your data block, and then compared with the another key comma value of another data block. So similar way this MapReduce engine will keep on compare, and then it will if any matches is found, then it will take for the next level process. If there is no match found for your business logic, then it will reduce from the data processing. So that's why even the 1 terabyte of data also it can able to process very quicker manner in the distributed data processing. So inside the MapReduce, within a Hadoop, there is a two layers of layers is there. First layer is the architecture. I'll tell you. This architecture is the Hadoop architecture, Hadoop ecosystem. In the Hadoop ecosystem, you can find the Hadoop distributed file system. The distributed file system is HDFS layer. That's a Google file system we have studied about, right? It will store and retrieve as a 64 MBs of data block. Then we have the MapReduce framework. The MapReduce framework you can able to find, and then the MapReduce concept is studied. It will map as a key comma value pair. Based on the key comma value pair, it will compare, and then it will process your data. If it is matches found, then it will move for the next level of comparison. If it is no match found, it will reduce the it will remove the particular data block from the next processing. So that's why you can able to process in a very faster way. The Apache Hadoop is having multiple other softwares also, like Apache Pig is there, Apache Hive is there, Apache Scoop is there, Apache Hbase, Apache Flume is there. So these are the additional software for your Hadoop. You can, if you are aware of Java technology, then you can do the Hadoop programming in the using Java. If you doesn't know the Java, you can use the other software like a Pig, Hive, Hbase, Flume and all for the big data analytical software. Okay, these are the additional tools for your Hadoop framework. Okay, so each block size is typically normally it is 64 MB. You can increase to 128 MB also, because since it's a logical layer on top of your hard disk, the Hadoop system, Hadoop software will create that HDFS layer. Okay, so now we'll move to the next thing. So you have to basically have to understand two components: Hadoop distributed file system and then MapReduce. These are two concepts you have to understand. So any doubt, any clarification so far? Any questions?
No.
Hello, Mani, can I
Yeah,
talk?
yeah, please.
You know, this MapReduce, that diagram that you showed, it had vertical lines, different layers, vertically positioned. Yeah, this one. Here, it's not I cannot understand how this is related to the HDFS. So how MapReduce is can go hand in hand with HDFS?
Okay, so this particular technology, how it is working under the distributed technology. If you are connecting 10 computer, each computer will have the Hadoop software. The Hadoop software will contain your HDFS layer, and then it will have the MapReduce engine. This two engine like a component. These components definitely must have for all the computer you are connecting into the server. Okay, here server is called master node, and then all other computer, whatever the computer you're connecting, it is called slave node. If you're connecting, if you doesn't have the 10 computer, you have only one computer in your home, you want to do process of 1 GB of data also, or 1 terabytes of data also, it is possible. What you have to do, you have to do the single cluster computer connectivity. That computer will act as the server, that computer act as the client PC. Okay, if you are connecting 10 computer, each computer you have to install the Hadoop software, the Hadoop framework. That framework containing your HDFS player, and then it is containing the MapReduce engine. When it is connecting client server model, like in the client server concept, you will connect server will containing one IP address, and client will containing one IP address. So the client is sending a request from this particular IP to server. Similar way here also, the master will act as a server and slave PCs are act as the client. So each computer will have one IP address. So each computer will be get installed on your Hadoop framework. The framework will containing the data processing. If the server is containing of any data, that will be transferred to the HDFS in one single place. Okay, if that data will be get transferred to the master node. So the master node will transfer the data to the entire client PCs. Each copies of 64 MB of block size will be have replication in the multiple computers. Okay, if you have 100 MBs of data or 200 MBs of data means this will be split into multiple 64 MBs of block. If computer 1 will containing your block 1, block 2, block 3. Okay, same kind of Hadoop, it is a network failure if anything may happen, or anything fault tolerance may happen. So Hadoop is making designed like a it will never fail. It will never fail kind of model. Okay, because it is handling large data size. If it is handling 1 terabyte, if you're copying 1 terabyte from one hard disk to another hard disk, if you are almost copied to 1000 GBs, during that 1000 GBs, if any failure is happen, the whole process again you have to recopy. So that will take very longer time. So that's why if anything failure on the computer 1, it will go back and refer the another computer where it has the replication of the data block. That block will containing the ID. Okay, the name node. The server will the server activity, what it will do here, master node, it will create, it is the job of splitting into multiple 64 MB sub block, put the name for that block. So that name of the block will be maintained by the master, and then it will be transferred to the client. Okay, this particular data block has been transferred to computer 1. This particular block has been transferred to computer 2. This particular block has been transferred to computer 3. So now this computer 1 will be take the MapReduce engine and then compared with the computer 2 of HDFS layer on the computer 2. So these two blocks will be get compared. So if the data match is found, then it will move for the computer 3 with the data blocks. Similar way it will map, and then it will reduce the data packet. So within this MapReduce engine, which will automatically process this particular MapReduce engine, it is an inbuilt component. It has containing the sorting, shuffling, all these things in the program itself. So we no need to create any program for this. Automatically, any data packet which is comes to the system, that system will automatically process the process your data in the MapReduce concept of key comma value pair.
Okay, thank you.
Okay. Any other question?
Yeah. So this I1 big ecosystem, which will in turn work on MapReduce or some other framework is available for that.
Okay, in the Hadoop concept, all the platform, all the software, all the additional software, it need to undergo only through MapReduce engine. It will never ever go for any other platform or any other framework. These two components, HDFS layer, Hadoop distributed file system, and MapReduce is the one combined component. And then these components, if you are using Hive, Apache Hive or Pig or any kind of software, it need to be get converted into a MapReduce program. Then only it will going to execute. If you are using developing a software using Java and then you are writing Java coding, then the Java coding will be converted into a MapReduce program, and then it will run. If you are writing the Pig software, Pig language using Pig or Hive, then it will be those compiler will convert into a MapReduce code. Then the MapReduce values will be work in the MapReduce framework. These two layers are constant. The MapReduce framework and then Hadoop distributed file systems are common components for any software in the Hadoop ecosystem.
Uh, but uh, but it looks like for HBase and Flume, MapReduce is not required, right? So will there be no distributed data processing there?
No, so there also it is required actually. The components there also it is required. So why it has been specified like that is the HBase is a pure database system over there. It is like a inbuilt data source can be available instead of MapReduce. Okay, in the HDFS distributed system, the Apache HBase containing the column like it has the inbuilt database. Okay, when you're executing any query, okay, when you're executing any query, that will be converted into a distributed data processing. So when you're writing the program, that will connect to your MapReduce. If you're writing the SQL kind of query, then it will connect to your MapReduce program, then it will execute in the Hadoop distributed system. There you can process either in the inbuilt of data source, or you can take the data volume from the HDFS. If you're having one terabytes of data, which data are available in the HDFS layer, then you can able to process through HBase to connect with your database. But there also the MapReduce engine will work. It doesn't mean that the diagrams showing here doesn't mean that HBase or Flume or anything will not touch for the MapReduce program, but every layer will process through your MapReduce framework only.
Okay, thank you.
So any other questions? So he is the person who developed this software, dog cutting, in the year of 2006. So he tested, he was working for Yahoo company. He started, found this version of Hadoop software. Then uh, first he tried for 100 computer in the Yahoo service. He tried 100 computer for the Yahoo search. So it has worked well. So based on that, he was launched in the big way of Hadoop other versions. Okay. So in the Hadoop architecture, we have to understand the name node, job tracker, and then data node. These three things are necessary to understand. It's a main important thing in the Apache Hadoop. So I told you there is no client server concept. It is a master and slave concept. Master will act as a server, and then slave pieces are kind of client. Okay. So here the code word, it's a technical word, is master means server. The server you cannot say as a server, it should be master, and then all the client PC need to be called as a slave PCs. Okay. This master node will containing as the only job is to create a name node. Okay, the particular server will have create multiple names for each data blocks. Okay, if you are putting the 1 GBs of data into your HDFS layer, when it's getting started, you can write once, read many times. In the HDFS concept, you can write once, read many times. So because we are not going to do an application development, we are going to do a data analytical. So for data analytical, you can write your dumping the data in one time. You can read for any times for your data analytical work. The name node, which is the job, is it will create any data block is coming for processing, it will put a name for the particular data block, like a serial number, like your the employee ID. So likewise, it will put a name for that. Then it will have the data block. So that data blocks will be maintained in the uh, metadata. In the master node, there is a database or a tabular column will be there. There it will maintain the list of data blocks and their name node, name ID, and then which computer it is getting processed and currently where it has been processed. So that will be maintained by the metadata information. Okay, the job tracker will maintain the what are the jobs are running under the which computer. If you are connecting 100 computer, the job tracker will maintain, okay, this particular job is running under the computer 1, this particular job is running under the computer 2. So that will be maintained by the job tracker. So in the slave PC, on the down of this particular regional server, task tracker, data node, these are in the slave machines. Okay, the slave machines are connected into multiple computer or in a like a rack. Like in the infrastructure, you can find the multiple small computers will be there, right? That big rack is containing around 16 different computers. As a 16 computer is called one rack. Okay, you can connect those systems so that each data computer or data cluster is called one data cluster. Each computer is called one cluster. So that cluster may have multiple sizes of data hard disk. In the data hard disk, you can store and retrieve the multiple data blocks. Okay, data nodes can be created. The data node is 64 MBs of blocks is called one data node. Here you can have the computer 1, computer 2, computer 3, computer 4, kind of any number of computer you can connect. The name node will just create a name for that and then it will maintain the metadata, and job tracker will maintain the which computer is processing on which node. Okay, so that is a slave machine. So for slave machine, whatever the data storing under the in the data node 1, that will have the 3 replication of multiple places, because if one computer get failure, it is go and refer to the other computer, so that your data will not be stopped anywhere, your analytical will be always perfectly working. Okay, so if master node is failed, what will happen? If master node is failed, you cannot process anything. Okay, so it is advisable to make the master node in a little higher configuration, and all slave nodes are normal commodity computer. Commodity computer is like a home PC, so that your investment cost will be very less. Okay, any doubt on Apache architecture, Hadoop architecture?
And also, so if they're all commodity PC, they can be any configuration, right? Like out of 10, 5 can be like very low end, 5 can be completely different.
Yes, it can be any kind of configuration. It can be one computer is having 4 GB, one computer may have 2 GB, one computer may have 500 GB of hard disk. It's not at all a problem. So you can have it in any kind of configuration. But it is advisable to that the whichever the computer you are deciding, you are making that IP address as a server, that IP address is advisable to make as a better configuration, so that it will never go down. Only the master, only one computer can be a better configuration. All other rest of other computers are normal configurations.
Okay.
And it can be any kind of different configuration also. One computer have Pentium i3, one computer have Pentium dual core, one computer is having 2 GB RAM, another computer is having 4 GB RAM. It's not at all a problem. Any kind of configuration is fine for the as a slave node. So there is a job tracker and then task tracker. The task tracker will maintain the what are the tasks it is currently processing onto the particular computer, and then it will send a heartbeat to master node every 30 millisecond. If any data block, 64 MB data blocks are going for processing, it will maintain a heartbeat to the server or master. So if heartbeat is not coming from the client node or slave node, then it will stop the process. Then it will decide that there is a network failure or there is a connectivity failure. So it will move that particular block to the some other data computer. Then it will start processing with that ID of that particular data block. So that's why it is creating the name node with a name and then data node. So this particular data node will be, if any data node's failure or any computer's failure, that will have 3 replication by default. You can increase to 10 replication also, 20 replication also, based on your number of computer you are connecting, so that it will never go down. If one computer is failed and second computer also go fail, then if third computer will work. If you want to increase the number of failure numbers also, you can increase. You can also reduce also. No need to maintain a replication. You can put a 0 also, but the Hadoop will not guarantee for your data failure. If anything's failure goes, that's your problem. By default, Hadoop has maintained 3 different replication to maintain your data processing will never go failure kind of model. Okay, so the MapReduce, just moving to the next slide. The MapReduce concept, as I told you, there is the inputs of multiple data blocks, 64 MBs of data block. Each block will be splitted and stored in your HDFS layer. HDFS layer is the logical layer. So from that logical layer, it will move to the mapping engine. That mapping engine will process your data block as a key comma value pair. The key comma value pair will be moved forward, and within that engine will have shuffling, sorting, all those things. So which data block need to be taken first? Which data blocks need to be processed last? So likewise, it will do the shuffling, sorting, and all. Then it is processing. It will compare with one computer of MapReduce value, MapReduce of data block, with the another computer of data block. It will compare the computer 1 data block 0012, another computer 2 of data block of 002. So if two blocks which is containing the data, what is the business logic I am writing? For example, I am having 1 lakh record. That 1 lakh record is containing 500 MBs of data packet. So each data packet will split into multiple 64 MBs of data packet. This data packet will one containing thousands of record. Another data packet will containing thousands of record. Okay, the thousands of record of data packet 1 in the computer 1 will compare with the thousands of record of data packet 2, and then it will compare. If the business logic is matching, the record is matching according to my business logic, then it will take for the next level. Okay, computer 1 data packet is matching with the computer 2. Then it will take to the next level processing. If the data packets are not matching, then it will ignore for to the next level of processing. Then it will remove from the memory. Okay, similar way it will always keep on to the, even it is 10 terabytes of data, it will keep on to the map and reduce kind of way only it will work. So once the result is found, what are the data blocks are matched? Only those blocks are containing your data. So that data packets will be given as a output. Okay, so that is your MapReduce process. So other Hadoop sub projects are we already discussed about this. So Hadoop HDFS layer and then MapReduce is the two combination of layer is called Hadoop software, and then we have other software called scripting language called Pig is the Latin script language, and Hive is the query language like a SQL software, SQL query. You can write SQL query. And then there is another software called Hbase. Hbase which is called NoSQL column of DB. NoSQL means it contains its own structure. The Hbase is the horizontal database. It will store and retrieve all in the horizontal way. So there is no row column kind of way. It will work in a different way of mechanism. Horizontally it will store and retrieve. Okay, it is similar to our Google Big Table concept. Okay, and there is another sub project called MathOut. The MathOut is the machine learning predictive analytical software. It will automatically learn, and then based on the learnings it will work. MathOut is the scripting language. So then we have the data extraction tool called as Scoop, Web HDFS, third-party tools. So many things are available. Most popularly we will widely use in the Scoop and then Web HDFS. And then there is another sub project called Workflow and Scheduling. It's called Oozie. Oozie is one of the software to make the scheduling your jobs, scheduling your activities, scheduling your workflow, how the jobs need to be done. So these are the way we can able to understand the Hadoop sub-projects and what are the other components are available. Okay, so this is a logical architecture. There is a multiple nodes connected on top of all the multiple nodes. All the computer will have HDFS layer. All the computer will have MapReduce engine. So this is a software component. It's very small software component. You can download and install in the any computer. So now we understand about the Hadoop ecosystem. So based on that, based on this understanding, we are going to learn the other components. So last week I teached about the Hadoop programming, and this week I'm going to concentrate more on the little bit of advanced technology called Hbase or Hive or Pick, whatever the software you require, we'll cover on that. Okay, so some of the basic commands are there in the HDFS file system. You can go through this. I'll share some of the videos on this. So each data block's data file is 64 MBs of data packet. Okay, you can also increase to 128 MB of data block. If one computer is having data block, will replicate with the 3 replications. Okay, if computer 1 is connected, and then based on that the computer 2, computer 3, here there are 10 to 15 computers are connected. One computer 1, it is having that storing the data packet for processing. The same data packet the computer will decide the next replication can be either in computer 5 or in 7 or anything, based on the current network speed, based on the current capabilities of the computer power. The computer algorithm will decide where it need to store and retrieve the replication of data blocks. Okay, so two things you have to understand on the Hadoop architecture. One is the name node, another is a data node. Okay, name node is just the master, which will just create a name for that particular data block. That is the only duty of master node. And then second thing is the data node will be available in the client PC. The client PC is called slave PC. The data packets will be get processed is called data node. It is a 64 MBs of data size. So another things you have to understand, files in HDFS are write once, and then you cannot able to keep on write many things. Write once and then you can able to read many times. So understand there is a master node and name node, both are same only. There is a two technical terms is there, master node and the name node. Master node and name nodes are both are same only. So one is master node and name node, and next one is the data node. Okay, the data node, for example, if one text file is there that has been 200 MBs of file, then it will be converted into BLK0001. That is a one block, first block. So BLK002, this is a kind of name automatically generate. It will generate a name for a particular block. Based on that, it will provide. Okay, so this is the format of how data nodes are storing in your computer. Consider there is a block 001 which has been processing in the computer 1. The same block 001 has been put across into computer 4 and computer 5. Okay, so each 64 MB block, this block 001 will not compare with your block 001. The block 001 will compare with the block 002 or block 003. So one block will be compared with the another block. If anything is failure is happening on the block 001 on computer 1, then it will move back to your block 4, and then it will take the block of block 001 from the computer 4. Then it will compare with the other data block. That's called map and then reduce. So this particular block will be as a value, and for this particular value will containing one key value. So the key comma value pair concept is map reduce. So each key comma value pair will be compared with the another key comma value pair of data blocks. So this is how the map reduce engine will perform your operation. Any doubt on data node and then master node?
Um, one question, actually not directly related to this slide, but we were talking about 64 MB.
Yes.
What if there are very small files that are less than 64 MB? Let's say 3 MB, 2 MB. is it not inefficient? How does it work?
No, it will also it will take that particular thing. So the beauty of the Hadoop architecture is in your normal computer, if you are storing the 2 MB, 3 MB file, what it will store as a zeros and ones. Okay, so if each block will be containing 3 KB, 3 KBs of data block. If particular block size is only 1 KBs of text file, then it will what it will do in the normal hard disk, it will store for only 1 KB, and then the remaining 2 KB file will not be given for any other file. It will be just wasted in the normal hard disk. But in the Hadoop architecture, it is in the logical layer of HDFS layer. If it is only for 2 MBs of file, for example 200 MB file, which has been split into multiple 64 MB block. The first one is 64 and second 64 is 128, and then third 64 you can put it across around 192 or 198. So then the remaining around 4 MB file, again it will create another block for 4 MB or 6 MB file. The remaining rest of the 60 MB file, 60 MB block size will be removed from that data processing. Okay, this can be occupied for other file usage. It will not occupy for 64 MB block. It will take for only for 4 MB file. Then the remaining rest of 60 MB file of storage can be as a free space, can be used by any other data block.
Okay, okay, thanks.
You said that main node is responsible for the job submission and it will track all the location of the data in data node. In case of any failure with the main node, for example, any natural disaster or network connectivity issue, is it possible to keep going with submitting job or to retrieve the data from data node?
No, if master node is failure, you cannot do anything. So it is advisable to make the master node in a little higher configuration. So that's one thing. If master node is failure, you cannot do. But if any slave nodes are failure, that is possible to move forward for the data node.
Okay. Is there any backup with the master node in case of any failure?
So there is a secondary name node is there. That secondary name node is not the backup of your master node, that is used for different purpose. So if master node is failure, it is the whole process failure, again you have to rerun the whole processor. Okay, there is no backup for that. So the master node should need to be always in a, it's just starting of a process. Okay, even the starting of the process is not available, then you cannot able to start your process. It won't take much time for running the entire application. It will just minimum of time only. Okay, so it never goes to failure, but even if it's get failure, because data are not processing under the master node, the data are processing under the slave nodes only. The master node will just a name only for each data packet. So if you are having 1 terabytes of data also, it will just simply create within a milliseconds of time. All your data blocks will be named for your 64 MB blocks, and then it will be get transferred, and then that metadata will be maintained in the master node. But the data blocks are maintaining in the slave nodes. That's why they're having the 3 replications over there on the multiple computers. Any other question? Okay, I provided some of the examples and exercise for writing a how to become a Hadoop developer. Maybe I'll share the some of the other videos. So based on that, you can understand how to write a basic program. Okay, in the meetup group, you can go and visit in the meetup group. You can able to find the how to install the Hadoop on your home PC. Okay, there is under the file sections, under the big data, under the file sections, you can go and refer the multiple documents, other things are available. One of the documents called how to install the Hadoop. Okay, just give me a second. So under the Hadoop, you can go and refer the Hadoop installation guide. So this installation guide will tell you how to do a Hadoop installation on your home PC. It will provide you a step-by-step guidelines for your installation process. Okay, so here you can go through that how to install the Ubuntu. Ubuntu is open source operating system. It is advisable to have the Ubuntu for your home PC. You can install Windows 7 and then Ubuntu alongside. Then once you are configured the Ubuntu, you can download the Apache Hadoop. So if you don't want to install the Ubuntu, if you want to use the Windows 7, then you can download the alternatively Oracle VirtualBox. So this VirtualBox will create your home PC of Windows 7 as the another inside a virtual PC. Okay, there you can download the Ubuntu software as ISO file. Then you can open through Oracle VirtualBox that ISO file. Then it is act as the virtual machine without installation. Okay, so here I given all the step-by-step guidelines how to create a virtual machine, how to install the Hadoop, how to download the Hadoop, from where to download the Hadoop, step-by-step of each and every steps which has been provided. Okay, so now we'll understand more on the Hadoop configuration. If you download the Apache Hadoop from the Hadoop's location, Hadoop website, the Hadoop can be downloaded from the hadoop.apache.org/release of download. This particular URL you can download. So you have to configure in the 3 layer. So you can configure the first you need to go to the Apache Ubuntu. Under the Ubuntu you have to create a username and group. Then you can extract the Hadoop zip file. In Ubuntu it's called tar file. Normally in Windows PC we will call it as a zip file. So once you unzip that all the files into the one particular folder, give the rights to the accessing for that particular user to access the files. Once it is done, you have to install the local host like a web server. So here there is an open source web service called SSH server. Normally in our IAS server we'll call it in the Windows server, right? So in Ubuntu you can install the SSH server. It's like a local host. For installing that you have to type these following commands: sudo apt get install OpenSSH server. Then you need to generate a SSH keygen. So every time it will not ask for your user ID password. For that only we are generating the SSH keygen. So once this setup is done, you have to disable this IPv6. Since Hadoop is running under the IPv4, so you have to disable in the configuration. Open ets.syscontrol.configuration and paste this 3 lines. Okay, then we are coming to the Hadoop configuration, HDFS configuration, MapReduce configuration. So inside your Hadoop folder, you can find these 3 different XML file. These 3 different XML file is the configuration for your Hadoop. Core site-xml, map-read site.xml, HDFS site.xml. So there you have to specify where is your Hadoop data. Okay, where is your file system? Okay, that file system we are maintaining over in this particular IP address like a 54310. That particular location you are putting your HDFS layer. Okay, so these particular things you have to specify your configuration in the /temp/Hadoop data. The value you are specifying over here. Where is your HDFS layer? Okay, so here this same properties you just copy paste on your core site-xml, and this property also you copy paste in your core site-xml. So then you have to copy paste the MapReduce. Where is the MapReduce jobs are going to run? So this particular localhost port number only, this MapReduce tasks are going to run. So this property copy paste on the MapReduce-site.xml. Then you can specify what is your HDFS replication. So the by default you can set 3, 5 anything. So you have to specify HDFS site.xml, these following property files. So once you set that, in the bars.src you have to open in the Ubuntu, then paste this home path. Where is your Hadoop folder location that you have to specify. The following command you can copy paste and then modify your based on your which folder you extracted, specify that path of your Hadoop. So once it is done, you can installation is done. To start the program, you have to log into your user. Then you have to start the Hadoop as the Hadoop name node hyphen format. This is a one-time activity. This Hadoop name node hyphen format, what it do? It will format your logical layer of your HDFS software, HDFS storage. Okay. Then to start your Hadoop, you have to just type the command called start-all.sh. This is the command for starting your Hadoop software. Okay, so then you can find the job tracker, task tracker. If you type the command called GPS, you can see everything is installed. So this port number, the local host, will be internally connected. For any job you are running, then it will be connected through these port numbers, and then backend it will run. The map reduce, job tracker, task tracker, data node, everything will be get connected, and then it will work for you. So any clarification on the Hadoop installation? Yeah. Any questions on Hadoop installation? Shall we move to the next session, next topic? Or anyone having any questions on how to install or how to configure the Ubuntu or Hadoop? You can get these files from this meetup group, Big Data Chennai chapter. Under that more, under the file section, under the file sessions, you can go to Hadoop installation guide. Okay, it will provide you the step-by-step guidelines of how to install the Hadoop on your home PC. Okay, so we are going to move to the next topic. Before that, I want to just cover this particular slide. The Hadoop architecture versions. Currently, it is 2.6 version. So 3.0 version also is about to release. Okay, the Hadoop 1.0, the first version, it is containing the HDFS and then MapReduce. Okay, in Hadoop 2.0, the HDFS layer and then Yarn, MapReduce and other. So previously, when the job tracker, task trackers are which are small components within the HDFS layer. Now they have organized those job tracker, task tracker, resource management as the Yarn. Okay, Yarn is yet another resource manager. So this particular Yarn, which will be maintaining your all your job tracker, task tracker, and MapReduce engine majorly focus on your map and reduce activities. Okay, so this is your layer for your Hadoop architecture. Okay, so Hadoop architecture, how it is working is there is a name node which is the your master node. Okay, the master node will create a metadata that containing the map, the name of the particular data packet, and then there is a data where is the replications are happening. So all the metadata, it is like a tabular column, like a registry. It will maintain all your what are the data type, what are the data blocks, because if you are taking 1 terabyte of data, it will contain thousands of data blocks. Okay, so it is need to maintain all the metadata, which data block ID. It may not be aware which computer is passing which data block. So that's why the name node will act as the master node. So master node will maintain all the metadata of what is the data block ID, what is the data block, which computer is getting processed, where the replications are having. All those things are maintaining in the master node. The data node, which is containing the 3 replications of each data block. It will be processed in one data copy, and then the same replication of 64 MB block will be maintained in the other data node. Okay, so that's called distributed data processing. The one data node will be compared with the another data node. It can be any location. This computer can be in the any geographic location. It's just only the IP address of that particular computer is required, and then there is a Hadoop software is required to connect the PC. Okay, so for 100 computer is available in the Bangalore location, 100 computers available in Delhi location, 100 computers available in the New York location. Not at all a problem. It's going to connect all your system in the distributedly environment. So it is going to connect your PCs, and then it will going to process your data power. If you're connecting 100 computer, you'll get a 100 computer power. If you're connecting 10 computer, you're going to get the 10 power of computer power to data processing. So that is the master and slave concept, distributed data processing. Okay, so big data is keep on growing in a very faster way. So try to learn this technology, because next 20 years this is going to be a major technology for the in the IT industry. Okay, I've given some step-by-step guidelines to how to install that I already showcased to all. So now we'll move back to the new topic. So last 2 weeks before I covered the PIC software. Now we'll just cover on the okay, today we'll cover on the Hbase. Okay. Okay, Hbase is one of the tool for your data analytical. Okay, Hadoop is one of the software. Hbase is one of the distributed column oriented data stored built in on top of your HDFS layer. So here also all the data are going to process under the HDFS layer. The data tables, the databases, everything going to store under the HDFS layer. In the Hadoop architecture, if you are not copying the file in the HDFS layer, you are having that file in the your local hard disk, still that can able to process your data packets. But it will not process in a very faster way. It will be processed in a slow way. If you are putting the files, your copy command, using the copy command, if you are transferring the files from your local hard disk to your HDFS layer, then only the MapReduce engine will work in a very faster way. Okay, so now we are going to understand the Hbase. Hbase is one of the database tool where you can able to store and retrieve the large data. Okay, Hbase is an Apache open source software. You can download this Hbase from your Apache Hadoop. So if you are a new learner, if you are a new beginner for your Hadoop programming, first you try to learn the Apache Hadoop programming. Then you start learning the PIC software. Then you start learning the Hive. Hive is the similar kind of SQL queries. What are the things are typing the SQL query, like insert, delete, maybe the update. These are the kind of way you are raising the SQL query, right? Similar kind of select query. Similar way only we are going to use the particular software Hive also. The Facebook and all developed using the Hive only. Okay, the queries whatever you are typing to get the data are taken from the using the Hive. So Hbase is one of the such tool for large data operations. Okay, so the data are logically organized in the terms of table, rows, and columns. So Hbase is majorly in a structure oriented of database. Okay, in the Hbase, how it is working here is it is on top of your HDFS layer. The data are stored and retrieved on the HDFS. On top of your HDFS means it has its own storage. It will act as a own DB. Okay, so this particular things will work as the separate database as a tabular values, tabular columns. Those things will work as the Hbase. Okay, Hbase is built on top of your HDFS layer. Hbase files are internally stored in the HDFS. It does not mean that Hbase is outside, does not mean that the files are stored in separately. All the files, whatever the data columns, rows, packets are everything created, which is also in the HDFS layer only. Okay, so now we are going to understand the architecture is very important. Okay, so here the Hbase containing its own database, its own table, its own values. What is happening here is, if you are writing 10 GBs of data in your HDFS layer, it will just write once, read many times. But in the database, inside your Hbase, you can write many times and read many times. Okay, the Hbase, which is the database, completely a separate space was given for database to random write, random read. Okay, so here we are using the map reduce this particular HDFS layer, which is processing for any other data source like a text file, image file, all those things you are storing. It is a semi-structured, unstructured, those things can be stored in the HDFS. But in Hbase, it's purely a structure-oriented data packet. For example, you want to a banking application containing thousands of tables, has lakhs and lakhs and millions of customer data are available. I want to process those data. You can import those data through connecting with the scoop. If you are having an SQL server, the data are available in the SQL server. You can import through scoop and then store it in Hbase. That Hbase will process in the horizontal ways of data storing model, and then it will directly go like an indexing model. If any particular software like in the normal SQL server, you have views, you have index, right? That will have index key and then directly it will go for the value. Similar way, the Hbase is containing the several index keys are available. Directly it will go for that particular horizontal row. So that's why it is very faster. Okay, compared to MapReduce, Hbase may be slower, but if in terms of reading and writing on the databases, it is a faster only. Okay, since the maximum data size can be processed over there in the 30 plus petabytes in the HDFS layer, but in the Hbase you can able to process unlimited of 1 petabytes of data. Okay, data size. Okay, now we are going to understand more on the about big data model, Hbase data model. So before that, I'm just going to read some of the questions in the chart window. Just give me a minute. Please suggest this is a better time to move into big data. Now I'm the web front end developer. So Suresh asked the question that is it a right time to move to big data? Yes, this is the right time to move to the big data and Hadoop technology, because this particular technology is most wanted technology nowadays, and then many other countries, maybe it may be very less for India. Most of the other countries, they are now adapting to the big data and then big data technology. So if you start learning this now, it will take at least 6 months time for you to become a Hadoop developer. So in 2017, you can become a Hadoop developer. You can shift your career to this particular technology. Start learning more and more in this particular technology. First, start learning the Apache Hadoop developer, Apache Hadoop programming. Start learning basics of Java. It doesn't mean that it is not required high end of Java knowledge. You start learning the Java language first. Understand the basic programming, how to write a Hadoop programs in the Java. It is very important to understand the Java. So you can start learning the programs using Java. So not only this particular Hadoop software, there are many private licensed models of software available other than the open source, like Cloudera is there, Hudson is there. So many other tools are there. We'll see one by one on this if time permits for today's session. Okay. Maybe I'll go through one particular. One second, I'm moving to that slide. Okay, so refresh your mind. If you won't take any notes, you can take from your notepad. And then Hbase, we are going to learn on the Hbase. Okay, Hbase data model is based on the Google Big Data model. This particular Hbase is being designed based on the Google Big Table. So Google maintaining the large data in the big table, that it is a kind of concept. It is based on the Google Big Data model. Here all the data values are maintained through key comma value pair concept. The map and reduce can able to process your data based on your key comma value pair concept only. So Hbase also based on, it will store and retrieve your key comma value pair. When it is comparing from one record to another record, what it will do, it will directly go to your key value of your index. Each data will containing your key and then value. For example, CNN is the one of the key. It's one of the value. It containing one key value will be there. So this CNN will be compared with the another data packet or another record will be get compared. Okay, so that will be very faster. Okay, so the Hbase will be maintained in the horizontal way. It has its own structure. In the Hadoop, they created this Hbase with the logical of, it has its own data type. It has its own structure. Okay. In SQL Server, if you consider there is a varchar, there is a string, there is a numerical number. Similar way, there is a data types are there. There is a table structure is there. Table creation model is there. Similar way, in the Hbase, they have their own structure. They have their own horizontal way of how to store and retrieve the each cell value very faster way. If you take the Excel, so Excel also will contain the rows and columns. We can store the values in the rows and column. Similar way of Excel, you find the Hbase. Each cell is containing the value. Each cell is containing the logical structure, organizing the large data in a logical structure. So that is the Hbase. Okay, consider there is a personal table, person table. There is a row ID. There is 5 crores of records are available in the particular table of census record across the India. We are taking census. We are going to do a data analytical using the Hbase. Okay, so normally if you consider the Aadhaar number, Aadhaar card, so many lakhs and crores and people's Aadhaar cards are maintaining. That software is developed using the big data, because you cannot able to store and retrieve the very faster data in the normal SQL Server or Hadoop, normal SQL Server or Oracle. This our Indian governments of the Aadhaar card systems also data are storing and retrieving using the Hadoop only, big data only. It has been processed. Okay, so consider we are having the large number of data table. How we are going to store these records into Hbase? How it is going to retrieve? So Hbase is a totally different concept of storing and retrieving your data. Okay, so here each row is containing a key comma value pair. It will store and retrieve as a key comma value pair. Okay, so that particular each record will be divided into multiple family. Okay, the family record means grouping of multiple columns. Okay, for example, the name and address is the personal data. Demography, okay, whether gender, birth date, any other demographical information is there, we can group this particular field into a particular column family. For example, if you are finding the global level of data, you want to process through region wise, Asian region, American region, Europe region. So if you want to group this data into a column family, if you are searching, instead of searching the entire database, for example, select star from a employee table. What it will do, it will select all the values of your table. And if you're putting the where condition, where employee ID is 2000, Then it will search, it will take the first record, it will find whether this particular employee ID is 2000 or not. Then it will go for second record, it will check for whether the employee ID is 241. This is a business logic. Okay, so each row will be just compared, and then if it is matched, the 2000th record is maintained, it is matched, then it will found. So it will also undergo for the all other records to match your business condition. But in the Hbase, they change the entire storing and retrieving of the concept itself. So how they are storing and retrieving is key comma value per concept. So in the key, each data, each cell value will containing a key value, and then the columns are containing as a column family, grouping of multiple columns, multiple field, that is called column family. So we are going to study more on the how it is storing and retrieving. Okay, so each column, for example, name is the one column, address is the one column. So these two things are combined as the personal data that we can able to name as a column family. Okay, so this is how it is going to store and retrieve your data. So consider here there is a row key and then timestamp column is there. So each data is going to store in the horizontal way. It will not store in the row, or maybe it will not store under the one by one. It will be horizontally, it will keep on have the multiple columns. Okay, it is a column specific. The storing and retrieving is the column oriented. Okay, the key values are byte array format. So they serve as a primary key for your table. So it is better to make it to index and far faster lookup for your this row key. This particular key comma value pair, why it is, how it is working is, it is a serving as a primary key, so that if anything is need to be required, it will directly go to that particular key, and then it will be it will take your record. That's why it is a key comma value pair. So the column value which is containing as grouping of columns are containing as a one column family. It is containing one or more related columns, grouping in the related field related columns as a one single name, so that it is faster to process. Belong to one column family, it can include particular family name dot column name. You can easily specify the column name dot particular column. Okay, for example, employee personal data dot employee name. I'm just moving to personal data dot name, personal data dot address. So if you take only personal data, you will have the all the columns of name and address, all those things. You can specifically move to the one column also. You can have the group of multiple columns also. So this is how it is going to store and retrieve your data in the Hbase. Okay, so here's some of the explanation how the columns are divided, how the name of the column, how it is grouped into a particular column family name. Here the anchor is the column family name. So this is containing your multiple columns. Okay, so the version number is specified as for time stamping purpose. Okay, so each cell value containing your byte array of value. So here the data type is called byte array. Okay, the data are storing in the horizontal way. Okay, it will be specified, it will keep on move the data if you are having one row in the row and column format, but here everything will be in the horizontal way. Okay, any question on the data model?
What is this row key? Is it internally generated? Or?
Yes, it is a unique value, it will be generated.
It is internally generated by the Hbase itself.
Yes, correct. It will be storing and retrieving as the key comma value pair. This row key will be generated in the unique value.
How do we use the timestamp for retrieving. Sure. So like, will it be easy for us to retrieve the values using the timestamp rather than queries?
Yes, it is very easy to using the timestamp. Timestamp is like a kind of versioning. Okay, if first version is updated in this particular timestamp, second version is using on the inserted in this particular timestamp. So it is be very useful for timestamp will be one of the field to identify or much faster way we can able to retrieve and store the data using the timestamp.
Yeah, no, what I'm asking is like if I'm going to insert a record or insert some records in case of Hbase. So is it going to return me the timestamp every time I insert something so that I know that these are the values that I have inserted?
So every time the timestamp will be put across into your particular table value, it will not going to return back to you, but it will maintain as a timestamp, as a column. Okay, each
So
record,
if I
what?
want,
Yeah, please go ahead.
yeah, sorry.
I'll show you 1 second. I'll show you here. So here, the T12, T11, T10. So this is a kind of unique ID timestamp which has been operation when it is operated during that time. There is a timestamp key will be generated. Okay, it's like a version number of the each row.
No, what I'm trying to ask is like if I'm going to query Hbase for some values, so I'll not be able to use the timestamp for querying purpose, right? Because I'll not know what the timestamp is.
Correct. You may not know that, but you can able to take that value also. If they're using query, you can do that. But here the key comma value pair will be directly fetched for your row key. It will be directly go for your row key, and then the value will be your column value. So here how the data are going to store and retrieve is apache-apache.com. Within your column, if you have any cell value, for that cell value also will have one key. Okay, this particular thing is for row key, is for indexing key. The timestamp also in a kind of indexing key. Okay, which index mode when it is being stored, it will directly, its main purpose is your row key only. There is a unique key will be stored on your row key. This has been generated by the computer. So this row key will be useful for your indexing of data. So whenever you are doing a searching of data, it will directly go for your row key and then it will go for your column. So this timestamp is for internal purpose to maintain your versions of your data.
So can we specify which column should be used as the row key?
Yes, you can specify that. This row key is the default column.
Okay. No, like that's what. So we can specify, for example, like anchor to be the row key or some comment to be the row key.
Yes, we can specify that.
Right. Thank you.
Any other questions?
Not from my side. Thank you.
Actually, in one of the slides, you have, it was mentioned that the column will not be part of metadata.
Come again, your question?
In one of your slides, it was mentioned that the column name, for example, name, address, birth rate, gender, like that column names, will not be part of metadata. Probably the previous one you just switched over, probably in the previous slide, not that.
1 second, let me move. Is this the one?
Not this one. Before the other gentleman asked you a question, you showed another slide.
Is it a one?
Maybe, yeah, here somewhere. Yeah, maybe. Yeah, Here it says columns are not part of the schema. See that second line after that, it says columns are not part of the schema.
Correct.
So if it is not part of the schema, how can we filter it? How can we use it for filtering data?
Okay, so in the Hbase, how they are storing and retrieving is totally a different kind of concept. Okay, it does not have a structure. Okay, you can able to organize in any kind of way manner, any way of method as a column family. It doesn't mean that this particular field only can be clubbed together, or we can define only this structure. You can modify to any kind of value as a column family. That column family, for example, here row key is cutting, and then here data, which is the column family height, and then role. This is inside of your Hbase. Okay, inside our Hbase, how horizontally data are stored. For example, the role you are specifying ASF, director, Hadoop, founder. These are the different type of row values. Okay, this row value will be compared with your column family values. Okay, maybe I'll teach you some more how table structures are specified. Then we'll come to this slide. I'll explain you for why the columns are not part of your schema. Okay, I'll come to this slide
Sorry
little.
to
Yeah.
just one quick question. So since this PK, I guess PK asked this question, I'm asking this. Like, so there's no join at all in Hbase, right? We cannot join two tables like we do in normal SQLs because we are just going to put the data into one group, but we cannot join them, right? Am I right?
No, there is join also is possible, but there is a not multiple joins are available. Few joins are available.
Okay. Okay.
Now the latest version, they are little modifying, but then the previous versions are not available.
Okay. Oh,
Hello.
cool.
Yeah, please go ahead.
Is compression available in Hbase?
Yes, compression is available. You can able to compress the data.
Okay.
Data compression is possible. Okay, so now I'll yeah, please go ahead. Question.
In this architecture, what is the use of compression? Is that for archiving or any practical example?
No, practical example is if it is a large data, if you are handling for multi terabytes of data, and whenever you are architecturing, when you are doing the architecture of your table design, or when you are doing the architecture of your structure of your schemas, or maybe structure of your families, during storing in a drive, you can able to create a coding for that to compress the certain data to make it in a faster way. It's not only for archiving, it is to make it in a compressed way to fetch the data in a very faster. So by default, it will go and refer to the rows and key, and compression will maintain for your much way faster of your data fetching.
Okay, so it automatically knows it is compressed, and only those objects will be uncompressed when it's retrieving.
Yes.
Okay.
This is mainly for transferring over the network, right?
Yes, it is mainly for, because if you're connecting from Scoop and then if you keep on downloading the content and then storing in your Hbase, okay, Hbase storing and retrieving is the totally different way. When you want to transfer the bulk of 1 terabyte of data, our result sets need to be again move back to your originally to your SQL server. There and all you can follow the compressions technique. If you want to transfer the large data of you are processing 10 terabyte of data in your Hbase, and then so for sudden data transfer you want to transfer from two different data source, then you can use the data compression.
Thank you.
Actually, I meant that whether you can compress the data in the original source itself, like in Hbase itself, and still query.
Yes, you can do that also. Yes, possible. Yes.
Does the compression impact on the performance?
It won't impact the performance actually. The performance here, based on the number of node you are connecting, based on the algorithm or business logic how you are writing, and then it is purely a key comma value pair concept. It won't affect your performance. It's purely based on the 64 MB data block, and then how many computers are connecting, how many systems are running. Based on that only the performance will be specified. And then the internal storing and retrieving method in the Hbase, how we are organizing your column families, how we are storing and retrieving. It is all about your how you are going to write a program for make it in a faster way. The system will work as per the key comma value pair. Whenever the key of row key comma values are there, they're just going to compare, and then it will going to process your data. It won't affect anything on the performance, but how you are going to write a program, there it may be possible to affect your performance of your program. Okay, let's move on to the next topic. Okay, so I want to specify the each particular cell, each particular version. So previously we talked about the timestamp or row key. Okay, how timestamp and then row keys are helpful for our data retrieving and data processing. Okay, so here consider the row key is a unique value com.cnn.www. It's a row key. Okay, this row key is containing multiple data records. Like it is storing in a different columns. The column families are specified in the table. Why it is specified is it has been organized. Each cell value will containing your unique key. Unique cell. Each cell value will containing a unique key. For example, the row key of timestamp of 5, which is containing this particular unique value. So similar way, if you are having 10 lakhs record, the row key and then column family will have multiple horizontal ways of big table. Consider that you are having a big chart. Okay, in a big chart, in a big whiteboard, you are writing all your data in a horizontally. If you want to find anything, you're directly going there on which exact location you want to find. That exact location is called key. It won't search for entire database. It won't search for entire table. It will directly go for your key, and then it will directly fetch your data, and then it will process. Such a way only it is designed the Hbase. That's why it is very faster, and then you can able to process terabytes of terabytes data. When storing, it will map as a key comma value pair. It will directly go for your key, fetch your value, and then it will compare for your data processing. That's where it is very faster. Okay, so now we'll understand more onto the another structure, physical model of your Hbase. Okay, each column family stored as a separate file. Okay, if you're having a column family of employee or personal data, then that is stored in a specifically in a separate file. It's called H table. Within Hbase, it's called H table. This H table, how it is working here is, if you consider you have 5 regions of data. In these 5 regions of data, you are putting that these particular columns are grouped together as a Indian region, and these data are grouped together as the American region. So these data columns are grouped together as the country. If you are filtering the country and then you are specifying this data are specified for European country. Okay, then the records are going to split into multiple cells. Multiple cells will contain each cell will be containing your key comma value. Okay, when you are comparing for multiple region, it won't search for European database. It won't search for American American database table. It will directly go for the where is the regional key comma value of Indian data records. There you can find that specific to the key and cell value. It will directly fetch that particular key value and then it will take for the processing. Normal SQL server, it will search for your entire data tables, and then if you have the index key also, it will go for that particular index key and then it will select all the records of that particular row, then it will take for a processing. But in Hbase, the storing and retrieving, it is a horizontally specified, so it will be directly fetch for your index key, the row key, and then value of that particular cell. So if 64 MB data block of that particular Hbase, the multiple row key, multiple columns, multiple values will be compared with the another 64 MBs of data blocks of records of key comma value pair. So here only your business logic code will be get compared, then the result set will be sent back to your as a record. So that's why it will work as the Hbase model. So Hbase maintaining the multi-level indexing. So here key comma column family, column name, timestamp. These four value will be automatically maintained by the Hbase. It is containing the key, column family, column name, timestamp. These four value will be maintained for a multi-level indexing. So if you have the large data, it will maintain a key, column value, column name, and timestamp. Consider an example. Okay, we are moving to an example how the Hbase is storing and retrieving. Okay, first thing, information is column family. Okay, the column family is row ID, row key, and then it has the two record. The two record is height, and then information is date. It's a column key. You have your own table structure. That table structure you are reorganizing as the column family. You have to create a table first. That table column should be containing as this particular column, that you are grouping this column as the column family. When you are creating a column itself, you have to specify these columns are this particular column family category. Okay, another column family is called role. In your table, for example, in your table employee designation is there. In the employee designation, there are 5 to 6 designation. Okay, for here, director, founder, PMC, committer, contributor. These are the 5 different rows are available. Okay, but I am grouping together as a one single column family called roles, and another column family called info. So these two examples I'm just providing. Based on that, I'm taking that value. Okay, now I need to understand how to create a column family. Okay, the timestamp is the unique value will be generated automatically. The row key, we can specify what is the row key. It's a unique combination of key value, key comma value per concept. Okay, so here the info column family, info is the one of the column family. That column family containing the height, state, value. Okay, so here the combination of row key, the combination of one-on-one, one to many combination was there, right? So similar way, all the many to many combination will be mapped on the column. Okay, here the roles, different type of roles will be just mapped ASF, director, Hadoop, founder. These are the different roles. These roles are mapped with your row key, and these roles are mapped with your row key. For example, cutting is the one of the type of row key, and that containing two different height and state, and then that has the values. So each cell value will mapped with the respective column value. Each cell value will be mapped with your respective row key. Each cell value will be mapped with your timestamp. So this is the structure for your data, how it is organized in the Hbase. So any questions on this?
Hi Manikan,
Yeah.
I have one doubt.
Yeah, please go ahead.
Here in Tibetan, in Rocky clip-on, for column family rows, we will have two columns actually, Hadoop, Hadoop. Is it possible to have duplicate columns in that column family?
Where you are seeing that?
No, in rows column family, we have two columns actually, Hadoop, Hadoop, Hive. We have columns, right?
Yes.
But we have duplicate columns, Hadoop and Hadoop. Is it possible to have duplicate columns in
Yes,
column family?
it is possible to have the duplicate column key, but it is not the row key. So the row key and then the mapping of all the things, the value will be definitely different. If the column
Okay,
key, if
when
you
we
are
are referring, okay. If you are having, sorry, in each column family, if you have duplicate columns, how we can able to retrieve data? I mean, if I say rows dot Hadoop, it will, which one will come, committer or PMC?
okay. So this particular role, the particular info, all those things are unique. Okay, it is not it cannot be repeated. But how it has been internally stored and retrieved for each record, how the data are mapped. For example, here it is mapping of the example role of column family for cell value. For example, you have 5 different records, director, founder, PMC. This PMC is one of the role of that has been inserted in the particular table and this particular timestamp under this particular role. This role of Hadoop is the uh, uh, one single unique value. It cannot be repeated. But here it is showcasing in the example how the each record is splitted, how these particular cell values are mapped with which column family, column key.
Okay, got it. It is same column but with a different timestamp.
Yes.
That's so unique value.
Yes, different timestamp and cell value.
Okay. But the column is same, one only. Like
Yes,
Hadoop
one
is
only.
column and it is having different values. Yeah,
Correct.
okay, got it. Okay.
So any other question somebody trying to ask?
Data whatever we are getting from Hbase is from only in JSON format because I can see the key value pair with set packets open there. Or do you have any other format coming from Hbase?
So normally it's a JSON format only. It is advisable to have the same format.
Okay.
Okay, I'm moving to the next slide. So we are going to understand more on the what is a column family. Okay, so we have to more deeply understand what is the different sets of column, how it has been patternized, all those things we are going to understand now. Okay, consider the Hbase regions. So each H table, so H table is the column family table. It is partitioned in the horizontally. So in Hbase, why it is Hbase means everything operations are possible only through horizontal. If the each region which is containing the data, for example, timestamp 6, timestamp 5, it is belong to this particular region means, then it is a unique value, unique key, unique region of data. Okay, so once again, let's move different slide. Okay, each one region will containing the particular row. Okay, the row value will be get compared with your column value. Okay, if you are processing your Hbase database, if you are storing the cell value which is containing certain data, this data may be linked with your column family. That column family will linked with your region. Okay, if you are processing any data, that will be compared with the specific to region. It won't search the data for entire database or entire H table. it will directly move to your partition of your table. The partition is very important topic in the Hbase. The partition here is you have 5 different column values, column family. These column family you are specifying these data are belong to this particular region. Then you can have a comparison of data with this particular region, like a partition of your table. Partition here it's partition also will be do it in a horizontal way. Each cell values can be partitioned, each tabular column, each column family can be partitioned as a group. Partition mean here grouping of these columns into a kind of naming in a region. The partition is a region. This particular things specifically these data are belong to this particular region, so that you can compare the large set of database, the large set of data to in a partition way. If you have 100 columns on your table, you're just partitioning these 5 to 10 columns are this particular regions related. Then what it will do, these 10 different columns will not be useful for your any other operation. When you are putting these particular columns, the region also need to get compared. This partition table will be used for your data operation. Okay, so partition is very important topic in the Hbase. Go and read in the internet on the more specific on this particular topic. Okay, now we'll move on to the HDFS architecture. Okay, so we previously studied about the Hadoop architecture. Now we are to more understanding the Hbase architecture. This containing the 3 major components. Okay, one Hbase master node. The master is been available, and then there are several regional servers are available. So the regional servers, which means the Hbase regional servers. It is not the master node, it is the servers. Okay, I told you related to American region data census are maintained in one computer. Europe region census are maintained in one computer. Indian region census are maintained in one computer. Okay, how the data can be grouped together from the many region servers can be imported to your Hbase client of your Hbase database. How we can able to connect? Then based on the connectivity, you can able to process the large regions of data volumes. Okay, there could be one master. That master key will master things will what will do? It will again will do a key comma value pair of putting that master node. Master node what it will do? It will provide a key. It will provide a name for that particular node. Hbase client what it will do? It will do a data node packet, the data packets. So in between a H region server will maintaining the multi-regional server data source. This data source can be within a client also, or if you having the multi-regional server, you can directly connect to that particular server also. Okay, so here region is the one of the subset of your table row. Okay, if you're any table, if you're having 1000 rows of horizontal data value, then the region, if you specify these records are belong to India, these records are specified to America, these records are specified to Europe. When you are searching the query, and then if you are putting the where condition based on the region, what it will do in the normal SQL Server table, select star from employee where country equal to India. If you specify, it will search all your 1 lakh record. If your 1 lakh employees are there, it will search all your employees of 1 lakh record, and then it will search whether your countries belong to India or not. It will search for, it will take the record of America data also. It will take the record of Europe data also. It will check for your countries belong to India. No, if India is not there, it is belong to America, then it will ignore the data row. But here, the Hbase is totally a different concept. It will not go and compare with your American region data. It will not go and compare with your Europe country region, because the Hbase are such a way designed to in a horizontal way storing and retrieving in the key comma value pair concept. Each cell value will containing one key value. Each cell value is mapped within a row key. Each cell value will mapped within a timestamp. So based on that, it will directly go to that particular value. For example, if I'm specified employee ID equal to 1000, where he belongs on the region of India, then it won't search for, it won't care about, because the partition, the Hbase is totally a partition based table. It won't go and search for your American data and then whether the data are available or not. The data not even consider for those data packets. It will data operations are will take only for the Indian partition region data, and then these data will be get compared with the another data packets of Indian regions of data packet. Such a way it was designed as the Hbase. Do you have any questions on this?
Yes, is this region something like a topmost key beneath which all the data is going to be stored in considering the JSON format of data?
No, region is one of the part of your table values. Okay, this has been partitioned value. It is like a partition name. Okay, it is a subset of your table row. Each row of value will have some range. Okay, this is columns. This is value. For example, row number 1 to horizontally this particular record or Indian region. If you specify the partition, these columns are partition. You have to explicitly specify that. So when you are designing the table itself, you have to specify partition. Like how we are creating a table. Create table, table name. And using partition, these columns are partitioned with this region that you have to specify. We'll see the examples over in the next few slides.
Hi.
Yeah,
Hi.
Manigan,
Yeah.
Jagan here.
Yeah, Jagan.
Hi. Is region and column family same, or how is it different actually?
No, region and column families are totally different. Column
Okay.
is the by default columns. Okay, and grouping of columns are, it's called column family. The region is the subset of your table. These column families are belonging on which region? It is like a partitioning. Okay, column family is
Okay,
grouping of column. Region, it's like a partitioning of tables.
So a
Hello.
region can have multiple column families also then?
Yes, a region can have multiple column family.
Yeah, got it. Yeah, thanks.
Hi. Hi.
Yeah.
Yeah, and Suresh here.
Yes, Suresh.
And you said by query regional wise, which is going to check, for example, India and America, you says like that.
Yeah.
But my doubt about in normal SQL, we can give by query itself whether it is present in India, it is going to be checked in India.
Correct.
Elsewhere, which is not going to check other countries like that. And which is available also in SQL. But what is the difference in Hbase for regional things entirely?
Okay, so here the key comma value pair, which is a very faster. Even in the SQL, you might have partition, right? But that partition work in a different way. Here, this partition will work in a different way. Each row key value will be compared with another key value. This partitioning of this table, not only partitioning of the column, it is partitioning for entire table, entire data values, entire key comma value pair. Each things will be get partitioned, so it will be directly compared to your direct to index key, kind of direct to, for example, if you have SQL Server table, you have index key or index ID. It will directly go and fetch your 1000 record. Similar way here, the row key is the one of the main unique key. It will directly go and fetch your row key, and here the cell value also will have key comma value pair. The cell value also, it will have some key comma value pair. So the data will be directly go and fetch your data cell.
Sure, thank you.
Okay, so Hbase components we have to understand the region server and master. For example, you are connecting multiple computer in the multiple region, but you have on commonly you are having multiple servers which is containing the data, and you have many slave pieces are running for your Hbase. You have 100 terabytes of data you want to process. Okay, if you want to process 100 terabytes of data, you cannot do it in a all the data stored in retrieve and process. If you have 100 terabytes of data, your business logic may suit for your 1 terabyte data. Your result set, your output of result set maybe comes from the 1 terabyte of data out of 100 terabyte data. What it will do, it will map entire data, but it will not going to process your entire data. It will check for, based on your business logic, which are the data blocks likely to be containing my data. Instead of processing entire 100 terabytes, the Indian region or US region or European region, the data are containing only 5 terabytes. To instead of processing 100 terabyte, it will go and partition the table, partition the data based on the region, and then it will go and fetch for the 5 terabytes. Now 100 terabytes has been reduced to 5 terabyte. Out of this 5 terabytes, it has been now reduced to key comma value, where I specified my select query as a business logic condition. In the Indian region, you have to go and search whether it is Tamil Nadu. I want to go for the partition. Again, I'm doing the another partition. These row data are containing the Tamil Nadu regions of data. Then again, I'm partitioning. These rows are containing Chennai data. Okay. When I'm partitioning, based on my query or based on my business logic, when I'm searching the data for Chennai region on particular index, then directly it will go and fetch for that particular cell ID, cell value. It won't search for entire region, entire data sets of 100 terabytes. So it will directly go for your row key, row index key, and then it will go for your cell value. That will be taken as the key comma value. That key comma value pair will be again compared with the another data blocks for your business need.
One question here.
Yeah.
This partitioning region, can this be done at any point of time, or is it only during the design stage that we will have to mention that the tables will have this kind of regions?
During design stage, we have to specify.
So after some point of time, if I want to add a region, like once I get to know
can
that the
modify
data
the query.
has,
You can modify the table query any point of time.
right,
But
okay.
it is
So
advisable to the architecture time itself. We have to design the partition in advance. You can modify any time of the partition.
Yes, but given the velocity and the volume of data, once I get to know that there is a pattern, and based on that pattern, if I'm going to group the data, then I can form a partition for that data, right?
Yes, you can do that. You can do that.
Right. Okay.
Any other question?
No. Thank you.
Hey, 1 second. I am getting one call actually. I'll take this call and then I'll come back to you. Yeah, I'm back. Okay, we are studying about the Hbase and then Hbase architecture, how Hbase is storing and retrieving the tables or values, how it has been partitioning. That is the things we are studying now. Anyone having any questions on this? Okay, we'll move to the next slide. So now we are going to study about the Hbase in a big picture, in a high level of architecture, how Hbase is working. Okay, so we are having the Hadoop system, which is having the MapReduce, which is having the data node. Okay, and in the Hbase, on top of your HDFS layer, it has its own data storage. It has its own table structure. Okay. On top of that, it has its own storing of mechanisms are available in the Hbase. But that Hbase also will have the 64 MBs of data packet. Okay. If you are having the data here, client PC Hmaster, the Hmaster is the master node. Okay, Hmaster is your master node. Zookeeper is one of the Hadoop tool for maintaining the infrastructures. Like in the infrastructure, some organization they have IT support, IT infrastructure, IT server room. So those things are they are maintaining, right? It's called data center. So the Zookeeper, which will helpful for your monitoring and managing your infrastructure of your data center of multiple region. Okay, if you are having thousands of computer, the thousands of computer, how we can able to manage or administrator, this Zookeeper's tool of Hadoop tool will helpful for you to manage your IT infrastructures of data centers using the Zookeeper. Okay, this is for server administration. Zookeeper is for IT infrastructure server administration. And then there is a Hbase regional server. Regional server. Okay, this regional server, it's the another layer. Okay, in this regional servers, there's several servers. You can have the US server or any distributed way, any server across the global, any different servers of database unit you can have. Under the regional server, you have regional datas. For example, I'm having the India server. This India server is containing data of 26 different states of data. I have another server which is European server. That server is containing the census of another regions of data. So now I want to do an data analytical. You comparing with the two different region. What are the people, their cultural, customer sentiment or anything. For example, iPhone is one of the product. I want to verify based on the people's customer record, who are the peoples or which are the regions are they are going to likely to buy my iPhone product or new launching the product. I can able to compare the data based on the previous historical data from the different region. If I'm launching the iPhone in the particular market in India region. So in this India region, which state the product will be promoted, which state I can able to promote my product so that my sales will be increased or doubled or tripled. I want to do a statistical analysis. Okay, for this I'm comparing, storing all the 1 terabyte data, 10 terabyte data from the various other sources of either from internet, Facebook or from Twitter. Some people they're talking about my iPhone, some people tweeting about my iPhone. Now if I filter all the Facebook data and then if I dump the 10 terabytes of data of Facebook and then if I study that analysis, now I got my target customer. Right? The similar way, I can able to do any kind of operation using the publicly available data or various information from the different source of data. I can do any kind of business logic. I can do anything. It's called value for my data. I can do volume, velocity, variety, and then value. This using my business logic idea, using the data packet, I can do any kind of operation. Okay, so these data packets are stored in our some servers or some data source. This data source are pulled out and then organized in the horizontal ways of data structure. That data structures are connected with your data node in your Hadoop. Okay, this is a big picture of your Hbase. Any questions on this?
Does the region server necessarily has to contain that particular region files, or can region files be shuffled across region servers?
The region files can be shuffled across to any region. It's not a problem. So here they are
So it's not like lost. logical grouping of region data is not there.
I'm not getting a question. Can you repeat that?
Let's say we have partitioned a table like India zone.
Okay.
India region. Okay. So is it necessary that I should save the data in the India region server only?
Yes. If you are partitioning in that particular region server, it is necessary to save the data in the particular region server, particular region partition.
Okay. Okay.
Because it is directly going to fetch your ignoring all other data packet. Because if I want to read and write of other region, compare the other region also, then it will take larger time. Then I'm doing the processing of entire 100 terabytes of data. Instead of 100 terabytes of data, I want to partition a smaller number of terabytes. That's why I'm going for a partition, and then region wise I'm going. So there again, if I'm not specifically done on the partition, then it is not a big data. We are processing the normal way of all the data packets we are processing for our data.
So while designing, when I'm specifying this partition, I must be taking into consideration the number of region servers I'm going to have also. Is it something like that?
No, it is not like that. This regional things you are partitioning in the within a table structure. There you can have the data packet. For example, I have created the regional. These particular rows, 100,000s of rows are available in the regional server 1, India data. In the regional server 2 is the European data. It might also containing my Indian server data, possibly if it can, but the partition cell value need to be get mapped with the regional, which is belong to India.
Okay.
When it is comparing with when it is pick the partition of this regional server of data, it will take 5 GBs of data from the regional server 1 and then half a GBs of data from the regional server 2. These data packets are fetched from directly to that row key and then cell value. Then it will be put into a data packet. That data packet will be converted as a data node of 64 MBs of data block. That data block is going to compare with the one data block to another data packet with the key comma value pair. The key comma value pair will be work in the map reduce manner.
This H region server, is it a physical server at all?
Hbase is the logical server, logical layer. Hbase tables.
No, I'm asking like the H region server we are seeing in this picture, right?
Yes.
Is it a physical server or is it just a logical server?
It's a logical.
Okay, got it. So there shouldn't be any problem in having a number of region servers at any point of time, right?
No, you are just configuring your Hadoop server, right? You can configure any kind of number of computer, any kind of IP address to specifically you can architecture that. For example, you have 10 computer. 10 computers are connected with your master node. Here H master is your master node. Okay. Here all the Hadoop data nodes are called different computer or data clusters. Data clusters. Grouping of 10, 16 clusters is called one rack. That one rack you can make it as a regional server.
Okay.
So now we are going to see the more on the how different data sources are coming from the servers or computers are managed. Okay, if I'm saying that these 16 computers are one particular rack. So the Zookeeper clusters, Zookeeper is one of the software which is maintaining for managing the large level of clusters. Okay, the Zookeeper is like a server administrator. The Zookeeper, there is a two type of role in the Hadoop. One is you can become a Hadoop developer and another become a Hadoop administrator. Okay, in this Hadoop developer, you have to read and write the how to do a programming, and if a Hadoop administrator, they have to understand the more on the infrastructure oriented of how to configure or manage the entire servers or regions, all these things. Okay, the Hbase is depends on the zookeeper, basically to manage the multiple layers of data from the various other source. Clear on this?
Yeah.
Okay. So now we are going to work on some examples in the Hbase. How to create a table, how to create a column, how to create a column family, how to do a partition. That is the things we are going to learn today. Okay, Hbase, here you are going to create a table. Okay, for creating a table, first you have to specify the what are the different columns. Okay, the last one you are going to specify create table, but before that you are going to specify all the column name and column family. We'll see by an example. Okay, one second, I'm just going for some examples. Let me find.
This is in Java, right?
Come again?
Is this in Java? This thing you're showing?
No. This is available within your Hadoop, within your I shown you the
Shell
how to install the Hadoop configuration, right? How to install the Hadoop. In the shell script window,
right.
terminal window, you have to similar way of how to configure the Apache Hadoop. Similar way you have to download the Hbase. Same thing, you kind of things you have to extract. You have to simply extract the in a particular folder and map the Hbase folder root path in the bus src. Then the Hadoop will work within your Hadoop. You can type the Hbase. The Hbase will get started.
Okay.
So Hbase is the database. Hbase is the pure database within Hadoop. On top of your HDFS layer, it will create as a database. That database you can create a table. In the table you can have the columns. That column containing the cell value. That cell value will containing the there is a how to read and write method is here. It's a get and scan method. Okay, we'll see one by one. Okay, to create a table, you have to create a first column descriptor, column name 1, column name 2. So kind of array kind of format you have to specify. That array kind of format, these are the columns. These are the columns or column family. The structure of your column family you have to specify. Then you have to add family columns of 0. Here if you have 10 columns, you can say add columns of families of 0, 1, 2, 3, 4. Likewise, you can specify. Then after that, you can specify the username dot create table description. Then it will be the table will be created. This is a syntax for your creation of table. Okay. So now we are going to how to get the value. Okay. To get the respective record from the table, you can use the keyword called get. Okay. Get of equal to new get of byte array. These things can be an example which you can write over there in the within your Hbase. Okay. If you are using the keyword get, that will get your record. It's like a select, right? Similar way of select, we are having a get. Okay. So we have another keyword called scan. Okay. Scan is the one of the hash tables scanning the record to fetch the records. For that, you have to create a code scan equal to new scan of what are the columns you are going to process. So add column. These columns you are going to consider for your search criteria. Here only you are writing the business logic. Using the data packet, what you want to going to perform. So the result scanner is htable.getScanner of scan. There you are putting that condition. Okay. So these things you have to write a code. These things you can use the Java code also. You can use the any other language like a Pig or Hive or whatever the language you want to use. The backend you can use for Java. Java is the main core language to use for Hadoop programming, but internally the Hadoop Hbase compiler will also read the syntax of creating the create table, scan, get, all the things are compiled by Hbase. You can use the same code in your Java also. You can call this code, okay, but you can use the same code, same line, the lines of code in the Hbase also. You can create a class file in your Java. There in the Java file also you can call this Hbase commands. Okay. If you want to get, if you are saying the get of some value, so each column value will contain your key and then value. Okay. So here the row key is called com.apache.www. It's a key value. Then the column label which is containing the value, anchor of apache.com. Okay, so this is how it will get. Scan also, it's the same kind of way. It will scan your entire table, entire row for your fetching the data. Get and scans are both the same functionality. If you want to store a record, you want to use the keyword instead like an insert command we are using, right? Insert of in the SQL server. Here we have to use for called put. Put is the command for inserting the new record. Okay, to insert a new record, you have to say put of new put byte array of row, put of add the column name, the column values. Okay, if you say put, it will insert a record or the existing key. You can append the new record. You can insert a new record. Any questions on this? Get, scan, put. Shall we move on to the next slide? Okay, so in the Hbase database, you can do the delete option also. Okay, the marking of particular cell you can able to delete, and also you can mark the entire column also you can able to delete. Okay, for that you can use the delete function. Okay, and next things we are going to study about the join. Okay, Hbase does not support the join. Okay, because here we are just storing and retrieving the column in the horizontal way. You cannot able to join the many to many or one to one, those things kind of things. It is not possible because it is containing the directly to key comma value pair concept. It has directly to the cell value that is connected with your row key kind of key comma value pair. It can be done through application layer call using the scan and get operation. So the Hbase does not contain support the joins, and the latest version they are trying to create the alternative for joins on this operation in the 3.0 versions and all. But normally the whatever the previous versions we are having, the joins are not available in the Hbase. How to modify your created table? Okay, this is the example to how to modify your table structure. To modify your table structure, you have to specify the table name, the string of table equal to my table. It is line by line, so you have to type this command in the line by line. One by one, you have to type the command in the Hbase compiler. If you have the terminal window, there you have to just type configuration config equal to Hbase configuration dot create. That's the first line. Hbase admin dot admin equal to new Hbase admin dot configure. String table equal to my table. So in that my table column, you are going to add existing new column or adding a new column family. Then you are going to add modifying the existing column family. Here only you can able to modify your column family. Then it will come for a partition. We'll go one by one. So altering the table, existing table, how to modify. So this is the command for your altering for your table.
Mani, this is Prasanna here.
Yep, Prasanna.
Mani, if you are creating any table in Hbase, then can we see the same table in MySQL? If you have MySQL connector and instead of Adobe, we have MySQL.
No, you cannot see that table in the MySQL, but you can have a MySQL tables can be imported. Okay, but you have to create a similar kind of structure into your MySQL also. You can import your data to your Hbase, and also you can export, but export in terms of you can export to the data only. The similar kind of structure you should need to have the column. What column you are going to export. You can have the data, you can export through Scoop. Using Scoop, you can import and export the Hbase data values. The results can be stored on the your MySQL. But the Hbase has its own structure, it has its own data table, H table. You cannot see the same kind of structure over there in your SQL, but you have to map what are the cell, what are the columns you are writing this when you are writing back to your other data sources like Oracle or SQL Server or MySQL. When you are exporting some tables value to that particular database, you have to explicitly specify these columns are belong to this entry, this particular column, particular field. So that you have to explicitly specify. But these configurations are belong to specific to your Hbase database within your Hadoop.
Sure. Thank you.
Mani, from Prasanna's question, I have another one question. Like in Hive, can we use this metastore? This H tables can be accessed?
Yes, you can configure the Hive also, but it's like an external connectivity. Through a kind of external connectivity only you can able to connect. But Hive and Hbase is totally different data storage. It has its own data structure. When you want to import a table from Hive, you can connect through connectivity of within a connector is there. For Hbase connector, SQL connector, MySQL connector, let's Scoop kind of model is there. There you can connect to Hbase. From there you can import your data. But it is not the Hbase or Hive data are not in the same area. Okay. Hbase is storing in a different location, but it is on top of your HDFS layer. Whatever the data dumping over there to the Hbase, that is also will be going to become a 64 MBs of data block size.
Okay. Yeah.
But when
So
creating
another
a table,
yes.
But when creating a table in Hive, we can see in MySQL itself. MySQL or any Postgres.
No, when you are creating Hive or Hbase, everything will be available only in the Hadoop only. It will not reflect in your MySQL or SQL. Once if you are creating a similar kind of structure in your MySQL, there only you can either export the data to your MySQL. Only the column, only the data only you can able to export, but not the similar kind of structure or the similar kind of entire dump over from the Hbase or to Hive to any other stuff. You have to create your own structure. You have to create a table value in the MySQL or Oracle or SQL. You can import that value and map to this particular column value. For example, there is a using the put command. You are putting the command, right? There you can specify this particular employee name can be put the value from this particular data source. That data source can be either from the directly from a HDFS layer or HDFS table or HDFS data packet of either text file or document file or Excel file. It can be structured or unstructured, that can be converted into a structured format. Then it can able to insert into a Hbase. But if you are having a 1 lakh record in your SQL server that you want to put across into a table using the put command, you can import through scoop. You can do a database connectivity. Based on the database connectivity, you can do a importing the data, insert, put the table value into your Hbase. This Hbase database will be available within your the node, within your master node, where you are containing your datas. Hmaster, which is containing your the database. Okay, so here you can find an example how the logging operation. Okay, so you can see the client put, delete, insert, key values, how it is happening. So there you can see the H region servers, different regional servers are processing your operation. For example, I told you if you are having the India data, it is available in the Indian region. So then you can directly put delete all those things, and then if you're saying that this particular rows, particular data are belong to Indian region, it won't save on your European region, it won't save on your US region. It will directly go to your Indian server, and then it will map to your memory storage of that particular Indian server storage. Then it will say this particular records are belong to India and metadata are specifically stored. So that is why it will be storing and retrieving will be very faster. Okay, so now we are going to see more on the how the Hbase deployments are happening, how the Hbase is working. Okay, consider you have Hadoop installed on your PC. You will have one master node that is called server. In normal terms, they will call it as a server, but in the big data concept, you need to call that as a master. Now all the client PC, in the big data terms, you should not call as a client PC. In big data terms, you need to call as a slave. If you are connecting two computer, you have two slaves. If you are connected one master and two slave PC, that means you have one master and two slaves. Here, the name node, secondary name node, Hmaster, job tracker, zookeepers are available in the master node. The other data node, data packet, task tracker, regional servers are in the slave node. The regional server also is a slave PC. The IP address of the regional server also acts as the slave node. The slave node may be connected with the multiple slave nodes, hundreds of computers, but only one master node will be available. So clear on this concept? Any questions on Hbase master and slave nodes?
Yeah, we are good with that, Manikandan.
I'm moving to the next slide. How Hbase is different from your RDBMS. We have RDBMS, we have Oracle and SQL, we have, that is also structure oriented. Hbase is also structure oriented. What is the difference between a Hbase and then RDBMS? We'll study about that. So here, the data layout in the RDBMS is a row oriented. It has a structure of row and column. all the tables containing the rows. If you have 1000 record, 1000 rows will be inserted. If you have 1 lakh record, 1 lakh row will be inserted. But in Hbase, it will not insert 1000 record, 1000 rows. It will insert in the column oriented. Column oriented means it is specific to the column. In that particular column, horizontally it will increase. In one row itself, you might have thousands of column indexed, thousands of values to a particular cell. Here, transaction is the multi-row ACID. In RDBMS, SQL Server or Oracle, it is a multi-row ACID. It will go row by row, multiple rows, it will go and read. But in Hbase, to make it enough very faster, the architecture of the Hbase itself, single row concept. In one single row itself, you have thousands of columns, thousands of values. But in the SQL Server, we'll have thousands of rows. Here, Hbase is thousands of column. It will, if you want to select 1000th row, it will search for all the 1000 row, then it will return the result from the RDBMS. But in Hbase, it will directly go and fetch your 1000th key ID, and then it will go and fetch your what is the exact column value you want get from the cell value. So that's a key comma value. In the RDBMS, we are using the SQL command query, but in the Hbase, it has its own structure, it has its own syntax, get, put, scan. There are several new keywords or new commands are available in the Hbase. In the security in terms of RDBMS, it has its own authorizations are available. Hbase, it is a previous model, there is no much security, not much more, but now there is purely secured environment in the Hbase. Okay, in the index, it is the arbitrary columns, the column oriented index. Okay, the index key will be column specific. Here in Hbase, it is a row key column specific. It's a row key. Okay, you can index based on multiple columns in the RDBMS, but here you can index through particular row key only. Maximum in RDBMS, SQL or Oracle, you can process the terabytes of level of data. But in Hbase, you can process many petabytes of data you can able to process in a very faster way. Here, you can able to read and write thousands of queries in a seconds. In 1 millisecond or 1 second, you can read thousands of queries, thousands of queries. But in Hbase, you can able to process millions of queries in a seconds. So you can see how much faster in the when you are comparing from RDBMS to Hbase. That's why it is very fast to do in a terabytes of data in a very faster way based on the architecture, based on the structure of your Hbase, based on the map reduce method, and then HTFS of data block size. Okay, are you clear on this? Any questions on this? Okay, we'll move to the next one. When we have to use for the Hbase. Okay, so you need to use the random write, random read, or both. Sometimes you need to read from the live data and then you have to store and process some of the content. Then you can use the Hbase. You need to do many thousands of operations per second. In a 1 millisecond or 1 second, you have to do thousands of millions of operations you want to do. Then you can choose for Hbase. Multiple terabytes of data packet if you have, then you can choose for Hbase. Your access patterns are well known and simple. In the Hbase, you can access very easily a particular cell value or particular column, particular row. So access is well known and simple in the Hbase. When the data are available to access, then you can choose for Hbase. If it is structure oriented, then you can choose for Hbase. So that's basically to well understand to Hbase. We'll see some more program on the Hbase, some of the commands in the next session. Okay, so meanwhile you understand and then go through some of the internet content or any other YouTube contents over there. Based on that, you try to learn how to create the table, how to read a record, how to put a record, how to get a record, how to scan. These are the basic commands. You can just pause this video and then you can take a screenshot and then you can use the same example on your terminal window. If you want to install, how to install, I'll show you in a minute. Once again. Okay, so here the first step is you have to go to Apache Hadoop. Okay, so here you can go to the apache.org. There you can go and find the tool called Hbase. Right, this particular website hadoop.apache.org, you can find all the tools: Pig, Hive, Spark, Mathot, Hbase, Crescenta, Ambari, everything, all the tools you'll get. It's open source. It is a freely available. When you click the Hbase, you can go and use the download session. Under the download, you can find the Apache Hive zip file or tar file. Okay, so there you can find that apache.hbase, the mirror file, the latest version. Okay, you can find the which version you want, the stable version. You can go for the stable version. There you can find the tar file. This tar file is the zip file for Unix or Linux version. Okay, you can download this first tar file. It's a 100 MB file. You can just download. This is the source of this particular software. Don't need to download the source. You can download the bin. Okay, download this and then you can use it for unzip this file, then extract in your this tar file in a wherever you install your Hadoop. Next to Hadoop, create a Hbase folder and specify, and then go to this particular Hadoop installation guide. There you can this basrc.sh, right? There you have to specify how you are specifying the Hadoop name. Similar way, export the Hive, the Hbase home equal to this particular path that you have to specify. Okay, so this is the exact locations you can able to find the Apache Hive, Apache, whatever the Hadoop software you want download, you can download from this particular website. Any doubt on downloading, installing any software? Okay, before closing the session, I want to specify two things. So this, if you are going and searching of Apache Hadoop, it does not mean that only these tools are available like Hbase, Pig, Hive, or Hadoop, only the open source tool. There are many companies have their own applications, their own big data tools are available in the market. For example, IBM, they have their own Apache Hadoop. They have their own big data tools. If you are taking HP is having their own Hadoop tools. They have their own commercial tools are available. Okay. If you Google this, maybe I'll Google it for you and then I'll tell you. 1 second. Okay, so consider the Apache Hadoop is the open source. Okay, the Apache Hadoop is open source. Similar kind of Apache Big Data Analytical. There are many platforms, many Hadoop big data softwares are available. Some of the software is called Cloudera. Cloudera is one of the private company. They have developed a graphical user interface of databases where you can able to run a Hadoop operations for your data. IBM is having their own data source called ANA. ANA is one of the things which is developed by IBM. Okay, and then Hudson Works. They have their own graphical user interface of Hadoop processing mechanisms. Microsoft, they have their own big data and then cloud environment for the big data operations. Amazon Web Service, it has its own big data analytical platform. Teradata, Oracle, SAP, these many companies are as most popular of big data analytical softwares are which is available in the market. Okay, clear on this? Any questions?
Yes,
Yeah.
Mani. So we have seen Hbase. I just want to know the difference between Hbase and Cassandra.
I am not have much knowledge about the Crescent actually. I have knowledge about only the
Okay.
Hbase.
Okay. Okay. No problem. Thanks.
Any other questions?
Yeah, Mani, we are good with.
Okay, perfect. So you can try the installing the these softwares. First, you try to install. If you are installing the in your local computer, then it is called once again. It's called single cluster installation. Okay, if you type the Google and then you can put the Hadoop single cluster installation, then you can watch the multiple videos in the YouTube or the other channels. Once again, single cluster setup. If you put the Hadoop single cluster setup, it will provide you the one computer act as the client and one computer will act as the server master. If you want to connect multiple computer, not a big difference from the single cluster to multi-cluster. Then you just type the multi-cluster setup, multi-cluster setup. There you can find the home path need to be specified. Then the IP address of the particular configuration that the core site.xml we have specified, right? This core site.xml. There in one place you have to specify the IP address of all the node. What are the computers are you are connecting? That IP address you have to specify. That's the only difference between a single node custom clusters and then multi-node clusters. If you have any questions on the installing this, post in our meetup group. Based on that, either some of the experts in this group they'll reply back, or I'll reply back based on the time. Okay, share your feedbacks, share your comments, share your content with the Big Data Chennai groups. You can send the file. If anything need to be uploaded, I'll upload in the more file session, and then you can go on the create a discussions in this particular topic or particular anything in the topic. So the people around the 3,000 people in this group, they can just post your the comments and the communications, anything that they can able to specify. Okay, so share this big data links, meetup link for your friends and colleagues, ask them to join to get the benefit. And then if you are anybody interested to take the classes for the public and then for the forum, for the help of other, you can just send an email to me. You can take your presentation from on behalf of other people. Okay, you can share your knowledge to the community. Okay, share your feedbacks on the comment section on this big data. and then based on that you can post it across, and then keep understanding. So tomorrow also we are having one session to understanding more on the few topics, and then understanding clarification doubts, and then the interview questions, all those things. So if anybody missed out today's class, also they can come up, and then tomorrow also they can understand more deep dive of this particular topic of Hadoop and then big data. There are a lot more to learn. I'm just giving the high level information and then high level knowledge to how to do that, and then some of the program how to do, and then there are a lot more to learn on this. I have so much of content and then so much of experience in gaining on this particular platform. Whatever I can able to possible to sharing with this community, I'll definitely do that. Okay, thank you for participating. We'll meet up on the next tomorrow or next week.
Thank you so much, Mani.
Yeah, thank you.
Thanks. Thanks, Maya.
Thanks, Manikantan.
Yeah, thank you.